This set of videos is going to cover section 4.2, which covers parabolas. So a parabola is defined as a set of points equidistant from a line called the directrix and a point called the focus. So the focus will always lie on the axis of symmetry, and the directrix will always be perpendicular to the axis of symmetry. So they want you to derive the formula for this, but we're not going to because it's kind of long. But essentially, if you have a point, for example, here, this point xy, it's going to be the same distance to this point here called the focus as it's going to be to this line over here called the directrix. And so every point is going to have that same distance. So if I pick a point down here instead, it's going to be the same distance to that focus point as it is to the directrix. So instead, we're just going to look at what the equations of these look like and the important pieces of information that we need to know. So we're going to start with parabolas at our vertex 0, 0, with a vertex at 0, 0, sorry. So the equation for a horizontal parabola is written in the standard form y squared equals 4px. So horizontal y squared equals 4px. Now p is the distance from any point on your line to the focus or to the directrix. So p is the distance from any point on your parabola to the focus or the directrix. If p is greater than 0, if p is positive, a horizontal parabola will open to the right. If p is negative, it will open to the left. So if it's opening to the right, it's looking something like this. If it's opening to the left, it's looking something like this. Your focus then is going to be at P0. So if we're opening to the right, we're going to move to the right. If we're opening to the left, we move to the left to find your focus. The directrix then is going to be a vertical line at negative P. So if we're at our vertex, we're going to move negative P, put a vertical line there. Down at the bottom, we're going to move it to the right. We're going to have a vertical line there. So then the axis of symmetry is along the line y equals 0. Versus when we have a vertical parabola, it's in the form x squared equals 4py. So I always remember the difference by specifically remembering our normal standard parabola we've always talked about that opens up. I know that this one is y equals x squared. So I keep that in my mind anytime I'm trying to remember which is which. I just remember the parabola that opens up is y equals x squared. So if it's one that opens up or down, I know the x term is the one that's squared, versus if it's opening right or left, that's when the y is going to get squared. So this time, if p is 0, we're opening up. And if p is greater than 0, if p is positive, it's opening up. If p is negative, it's opening down. This time to find our focus, we're going to move up. If we open up, we're going to move down if we open down. And our directrix will have a horizontal line this time, either below our parabola or above the parabola, depending on which way it opens. So the key with these are these important pieces of information. Okay, which direction does it open? If it opens up or right, P is positive. Down or left, P is negative. And is it a horizontal or is it a vertical? Is it a right or lefter or an up or downer? So essentially, we take what piece of information they tell us. So they tell us here the focus is at negative 8, 0. So I graph that point, negative 8, 0. That's this one right here, negative 8, 0. The directrix is the line x equals 8. So I know the y values can change, but x is always 8. So that means we have a vertical line here. Now, just looking at those two pieces of information, I should see from my graph that I know it should open left. Just knowing that, it's going to tell me some important pieces of information. I know that my y term is going to be the one that's squared, and I know that p is going to be negative. P is going to be less than 0. As we're working on this, we know that, again, our vertex is at 0, 0 to start with, so that's also a helpful piece of information. So the main thing we're looking for now is this p value. Well, the p is the distance from your vertex to your focus, and it's the same distance to your directrix. So this is, here is P, this here is P. So since we know our vertex is at 0, 0, we know that our P value should be 8 because it's got a length of 8 to get to our focus, a length of 8 to get to our directrix. And again, because it's opening left, that means that our P should be negative. So once we know that our P is negative, we take the standard form of a y squared equation. So y squared equals 4px. We plug in our value for P, and then we end up with our equation y squared equals negative 32x. So this time we have our focus at 0, -2. Make sure you watch the scale on these. 0, -2. The directrix at y equals 2. So I know the x values can change. Y always has to be positive 2. Just from looking at this, these two pieces of information, I should be able to see that it's going to open down. Once I know it's opening down, that's telling me it's going to be the x squared is the term, because an upper downer is our y equals x squared portions. And because it's opening down, that means, again, that P is going to be negative. So this is going to be a horizontal directrix. Means that it's a vertical parabola. That's what it means when it opens down. So we can confirm that the vertex is at 0, 0, because the x-coordinate of the vertex is the same as the focus, which is 0. The y-coordinate should be halfway between the focus and the directrix. The focus is at -2, and the directrix is at 2. So that means it's 0. Again, we're just confirming our vertex here is at 0, 0. So remember, our distance P is the distance from our vertex to the directrix and our vertex to the focus. So this is telling us then that our P value should be 2 because it's a distance of 2 to get there. It's a distance of 2 to get there. But again, P has to be negative because it's opening down. So this means our P is -2. So the equation for a vertical parabola, we said it's our x squared. So x squared should be 4py. We said that our P value was -2. So this means our equation is going to be -8y. Now, you can actually check these in your calculator when you are graphing, but you have to be very, very careful. So remember, our calculator has to solve for y before you can graph it. So in this case, if we've got x squared equals -8y, we need to solve for y before we can graph it. So we'd have to divide everything by -8. So if you want to graph this in your calculator, you'd have to graph y equals -1/8x squared. From there, you can find your coordinates, a few that will fit for your graph. So it looks like I should have one at 4, -2. Sorry, my stuff is in the way. And then at -4, -2. And also looks like we've got some at -8, -8, and +8, -8. So when I graph my parabola, it's going to look a little bit like that. So let's try a couple more. So our focus is at 2, 0. Directrix is at x equals -2, so that's going to put it there. So what I can tell from that, I know it's going to open to the right because it's opening. I also know that my vertex is 0, 0. So because it's opening to the right and my vertex is at 0, 0, I know my P is going to be a +2. Opening to the right means it's going to have a positive P value, and it's that distance here, so P is going to be +2. Since it's opening to the right, I know it's going to be a y squared equals 4px. So plugging in the 2, I should get y squared equals 8x for my equation.